In this video, I will show how to use the alternating series test to determine whether a given alternating series converges absolutely or conditionally or diverges. So before we use the alternating series test, we have to make sure that the limit of the nth term as n goes to infinity is equal to 0. Here we have infinity over infinity type of limit, and we can use the L'Hopital's rule. So replacing n with x and differentiating the numerator and the denominator, we get 1 over 2 to the x times ln 2, and this is equal to 0. So the general term goes to 0. Now, in order for us to use the alternating series test, we have to make sure that this sequence is positive, which it is, and the last condition, we have to make sure that this sequence is decreasing. So to make sure that this series is decreasing, we're going to establish the following inequality. That is, I have to show that n plus 1 over 2 to the power n plus 1 is less than n over 2 to the n. And let's multiply both sides by 2 to the power n plus 1. So we get n plus 1 on the left less than 2n, and subtracting n from both sides, we get that n is greater than 1, which is the case when n is greater than 1. So starting at n equals 2, this series is decreasing. Therefore, alternating series test applies, and therefore this series converges by the alternating series test. So the next question is, does this series converge absolutely or conditionally? To answer that question, we have to consider the series made of the absolute values of the terms of the original series. That is, we have to determine whether this series converges or diverges. So this series, I believe, converges, and we can do the ratio test, for example. So to do the ratio test, we have to take the n plus 1th term and divide it by the nth term and make sure that that ratio is less than 1. In this case, we have 2 to the n, so we have n plus 1 over 2n, which is equal to 1/2, which is less than 1. So the series made of the absolute values of the terms of the original series converges. Therefore, the original alternating series converges absolutely.